two guest speakers during the semester. This is the first one. We'll have another one. I believe it's April, sometime or another in April. Okay. Tonight we have an alum, Purdue alum, and this person is a dual major, was a dual major from industrial technology and industrial distribution. And in 1992 was a senior at Harrison High School and went through what they had at that time, the ICE program, which go to school in the morning, go to industry in the afternoon. So she started working with Caterpillar as a senior in high school. Okay? When she graduated from high school, started into college, then she was an intern at CAT for all through her college career, and then was hired by Caterpillar, and I believe started in procurement and supply chain. Okay, worked there for a while, and then TRW contacted her and said, we'd like for you to work for us. And went over to TRW in supply chain. Worked there not more than 2 years. And Ingersoll Rand Corporation called her and said, hey, we want you to come and work for us. So she went to work for Ingersoll Rand Corporation. And when she was at Ingersoll Rand, she was applied to San Diego and was in charge of purchasing the non-ferrous material, millions of metric tons of non-ferrous material for Ingersoll Rand's division of Schlage, Lock and Key. And what's interesting is that she's bilingual, and when she went to in charge of plants in Mexico, then she was down in one of the plants, went in, and she was sitting there listening to the conversation, and they did not know that she was bilingual. So they were kind of insinuating, what is corporate doing sending a woman down here to tell us what to do and how to solve our problems? So she sat there for a while, and then some kind of a question came up about a process. So she answers them in Spanish, and she said, Dad, this whole thing, atmosphere changed. Because they found out she knew what they were talking about. So when she was still working with Ingersoll Rand, Caterpillar says, tell you what, we want you to come back to Caterpillar. Process improvement engineering, working in her, I'll let her tell you what she's involved with right now, but going through a lot of the certifications and being Black Belt Six Sigma as one of her qualifications, and also in charge of the certification of processes for the new Caterpillar plant that's being built in China. Okay? This is Becky Luark, and I'm sure that some of you already know or guessed it, but this is my daughter, one of my daughters. So, I'll let Becky tell you about what she's doing. She's been now with CAT 15 years, totally, and so has quite a bit of responsibility, and works with, has been supervisor starting out on the manufacturing floor, in assembly, machining,
huge plethora of plants that you could go to work, consisting of building anything from engines to skid steers to forest equipment to mining trucks to just about anything construction or mining related, they have it. So we'll talk about that in a minute. I did the weekend master's program while I was at TRW and Ingersoll Rand. So talk a little bit about, I don't know if you're thinking about continued education later, but it's something to think about. I know you're trying to probably just get through your undergrad, but it is important to be thinking about some type of continued education after that. And what I did is I worked while I did it, so I didn't have to pay for it. So I basically got $20,000 of company-paid funds to go to the weekend master's program, which I completed through the College of Technology. So something to think about if you are working for a company and they're willing to pay for continued education is a huge, huge benefit. So, as you mentioned, I TRW and Ingersoll Rand, and then I came back to Caterpillar and Lafayette. So I'm going to tell you a little bit about CAT first, and then I'll tell you a little bit more about my experiences there. So you probably all heard of Caterpillar. It's a huge company. It's actually the world's largest manufacturer of earth-moving equipment, diesel engines, and natural gas engines. So the world's largest in all three of those categories. Also the second largest licensed trademark. So it's well known throughout the world what Caterpillar does and what they do. So in Lafayette specifically, the Lafayette plant was opened in 1982, about 1.3 million square feet. That's a list of things that we assemble, and I'll go through a little bit more detail, assembly versus manufacturing, because it is kind of important to understand the difference. So those are just model numbers of different engines that we manufacture, or that we assemble. And then on the manufacturing side, we have blocks, heads, rods, cranks. Those are all internal components to the engine that we'll say are very performance driven. So if those types of components aren't working correctly, you're going to have some major problems with an engine. So if you know anything about engine technology at all, those are major components that we really pay attention to. And that's why we manufacture them in our own facility as opposed to having someone else do that. If you guys want, you guys can see some of this. This is an engine with a genset attached to it and also a radiator. So many of these are shipped throughout the world. We build probably around 40 a day now, different size engines. And I'll go through this a little bit later, but many of these are used for electric power generation. And so that's what this is. This is a model of a genset. It's actually a 3516 genset, which means that there's 16 cylinders. It's got a generator and a radiator on it. And these are used a lot to power grids. They're used for prime power, continuous power, backup power, lots of different things on electrical generation. As I mentioned, the world's source of power. You'll see lots of different applications here, and I'll kind of go through specifically what our plant does. It's kind of hard to wrap your mind around, but there are so many applications for these engines. This is a marine application. We sell to not only our own Navy, but other countries' navies as well, making sure that all of their equipment is running. We have a lot of our guys who are marine certified, and so they go out into the facilities, into our customers, and help them keep everything running correctly. I don't know if you know this about Marines and ships, but many different waters across the world have marine certifications. So you have to be certified to run equipment in that area. So we have to have we have an entire group of people who do nothing but marine certifications. So it's quite important. It's a big part of our business. Petroleum applications, this is huge. As we're looking for well fracks to frack gas, as we're doing oil rigs, as we're doing any type of petroleum applications, gas lines, pipelines, we use all of our engines to do that sort of thing. Vehicular applications, some of our engines are larger and they don't go in many applications, but they do go in some. This is the largest mining truck that we build. This is a 797. And you can see the little picture down at the bottom, that's a skid steer. So like a Bobcat is the other brand for that. It's a skid steer loader, so you see how small that is. And those are a decent size, so you can kind of grasp how big that mining truck is. So that is the largest one we make. By the way, this mining truck actually has 2 engines in it. So one of those engines, we actually take 2 of them and we put them together. So it's actually 20 cylinders. Yeah, it's actually 20 cylinders to 24 cylinders working all in an engine together. 2 engines coupled together to make this truck run. So from our Lafayette plant, here's kind of the breakdown of what we sell. Electric power is about half of our business. Petroleum is about 20%. Marine about 9%. Industrial and locomotive, we have a lot of locomotive business, not a lot, but some. 3 to 5% that fluctuates. And then what we call captive is what goes into the Caterpillar branded product. So mining trucks or things like that that we will make an engine for based on our own equipment at a sister plant. So these vary greatly by what's going on in the world. So as different countries have different issues, where China, for instance, they're wanting to put a lot of construction in. So we have a lot of construction equipment going into China. They also have electric power issues. China, as they're becoming a more developed country, they have issues with losing power a lot. We'll be working with our China plant all the time, and they'll get power outage. So some of the things that they're working on is to get more power to their grids, to get more backup power. So electricity is very important to them right now. So these things fluctuate year by year. So, the petroleum market, it can fluctuate all the way up to 30, 40% of our business. So it really is dependent on everything that's going on in the world, and dependent on governments and regulations and events that happen. We will see surges in our business for the Olympics coming up. If the Olympics are coming up that year, we'll have electric power just kind of go through the roof because you're going to have to provide all kinds of power for the Olympics. So different events like that can drastically affect our business. These are just some more pictures of our engines in use. One I thought was kind of neat is they've got 10 engines up there all running together. That's at Temple University. And then as you can see in this plant in Australia, these packages are actually running on coal mine gas. So, and I'll talk about that a little bit more later, some different types of fuels that we run. But those are actually running on coal mine gas. And then you see the cement plant in Illinois, and then some natural gas engines as well. So that's just some applications that we have for our gas engines. I will say this, about 60% of the product that we ship out of Lafayette goes overseas. Maybe close to 70 right now. So one of the things that we're doing, you can see this is in the UK, where else? Canada, China, Germany. What we're trying to do is take some of our manufacturing. We are the only plant that manufactures this type of product here in Lafayette. So we're trying to take some of that manufacturing and get it closer to our customers. So we're working with our joint venture in China. They're going to be a plant that's going to be up and running. What we hope to do is be able to sell more engines to that market by providing them faster service. If we build an engine and you put it on a ship to get it across the ocean, it's going to take a long time. So the lead time, and that's one thing that customers are very dependent on, is lead time. We're trying to shorten all of that by building facilities that are closer to all of our customers. So if our customers are in Japan, if our customers are in Germany, wherever they're at, we want a facility close to them so that we can get them product quickly. It also serves so we can get them service when they need it. So if something's wrong, we have service people stationed throughout the world, so we'd be able to get them service as soon as possible. And one thing that's interesting, Lafayette does this a lot, is we have some mechanics that are just fabulous, fabulous mechanics. They're on the floor building engines, they're troubleshooting, to customers having problems, we will send our technicians from the floor. Sometimes they know more than our engineers, and they work with our engineers, of course, but they're troubleshooting these types of things all the time. And so we'll send those guys out to these facilities to work directly with our customers so that they can get their problem solved and get engines up and running. We have and you're probably familiar with this from the mining facilities that you've worked with, but in the mining industry, if your engines are down, if your trucks are down, you're losing just millions a day for having equipment down. So anytime that we have mining equipment down throughout the world, that's one of our first focuses to have people out there fixing the mining equipment, because mining operations are 24/7. So one thing I wanted to kind of talk to you guys about is, I know this is the 104 class, so I don't know how much you've had of manufacturing or assembly or processes. And can you guys tell me how many of you have had an internship? Anyone? Good, good, good. Okay, so if you've had an internship, you start to see some of these processes that I'm going to talk about. But this is just a list of just about every job I've had. And the nice thing is, with bigger companies, and I'll talk about this later, with larger companies, you can actually move around quite a bit. So in the office, you know, I said I did an internship, and then I went out to the factory. And then all of those things listed under supply chain, all of those things are, you know, supply chain related, where you're working with suppliers to bring in material to the plant. The thing that's interesting, though, is you'll find, as you move through your career, as he mentioned, I started in procurement, which actually you're bringing parts into the plant, making sure that you have material to build with. But then I became a logistics engineer, and in this role, what you do is you find better ways to bring in product. So as a procurement analyst, you're kind of struggling every day, making sure that you have all your parts in, making sure that assembly can build and such. But then as a logistics engineer, you have the opportunity to develop those plans. I know that Dr. Newton used to teach a class called Marketing Channels. I'm not sure if that's still here or not, but those types of classes help you try to figure out what's the best way to bring product in. So I had several projects where I was able to set up channels for product that can come in faster. You guys have heard of just-in-time product and inventory reduction, those types of things. So that's kind of what the logistics engineers help do, is bring product in more efficiently. And that's really been the case with several of these types of jobs. He mentioned that I was in the factory and I had distribution, I had test area, I had paint, I had assembly. So as a supervisor, you're dealing with the day-to-day, trying to get material out the door, dealing with, you know, personnel issues, those types of things. But then you can see under factory management, I moved into process improvement. And moving into process improvement, you can help the supervisors who are there, or the supervisors that are going to come after you, to say, hey, here's how I can make your process more efficient. So you're kind of doing an overall look at how things run in the factory and trying to improve those so that it makes it easier for everyone to work there. So I've had several opportunities where I've had, you know, I was able to kind of get in the rat race of the day-to-day job and then kind of move out of that and become a process improvement person to help the next people going through not have so many headaches. So that's kind of a really interesting thing about allowing me to move throughout the corporation. So I did look up some of the current classes that you guys have, and I just kind of lined them up with what jobs that I've had and how those classes have helped me. So this might be helpful to you guys to know. In some of the early ones, the internships, you know, some classes like this, industrial safety, those types of things really help me out. As you move on, factory management, I did a lot in supply chain, and really supply chain is kind of company dependent. You have to learn their systems. A lot of companies use SAP, so if you have the opportunity to work with any SAP software, a lot of companies are going to that. CAT's a little bit behind, we're not there yet, but we are moving to SAP eventually. So that's why it's more, I guess in supply chain I found it to be more experience related job, on the job experience as opposed to classroom work. directly into what you're doing in the factory. I mean, directly. So any of these classes that you guys have had or will have, you'll absolutely use these in a factory setting. And it's not just our factory. I've been in hundreds of factories, and many of them use these same types of principles every single day. A couple things that I found really interesting is when I had some of these jobs where you're working with suppliers or manufacturing or process improvement, you really rely on statistics and quality control. I don't know if you guys have had this class yet. It's one of my favorite classes. Who teaches that now? Who used to? Does he still teach it?
Dr. Stevens.
Dr. Stevens does now, okay. I had Dr. Stevens too. So in many of those classes, you're using what you learn there to improve the process. And not only did I do this with our own factory, but I did it with suppliers. So working with suppliers for many, many years, you have the opportunity to go in to many other plants and they're providing product to you, but the product that they're providing to you may or may not meet your standards. So going into suppliers and being able to work with them to develop a process is huge. And I relied on many of these things, many of these classes and what they taught in order to do that. So a lot of times when you're working with suppliers, they're the experts in making their parts, but yet you have to come in and give them suggestions on how to make them better. So that was kind of interesting. So engineering was the same way. This is really the first time that I've been in engineering, even though, as he mentioned, I don't have an engineering degree. I have all technology degrees. But working in engineering, you tend to learn a lot about how engineers think more on a theoretical level, maybe not necessarily on a practical level. So as technologists, what's really interesting is you've had a lot of labs, a lot of hands-on. Most people in technology, they work well by seeing the process. So I would definitely use that. Sometimes, at least in my experience, engineers sometimes kind of get lost a little bit in theory and formulas and structures, and they don't necessarily come back to a practical state. So this, not always, I'm not stereotyping engineers. I love all the engineers I work with. However, there are some that you see all these books on their desks, and I'm thinking, you still use this crap? You know, they have all these algebra books and trigonometry and everything on their desks that they're still using. And really what you need to do is just look at the part, figure out what's wrong with it, and do a more practical kind of analysis of it. I did bring a part with me. It's really heavy, so I won't pass it around, but this is a piston for one of our engines, and it's actually a casting, which I'll talk about in a minute, but I got this from one of our engineers today, and I said, hey, just let me borrow this for this class. But that's one of the things that he was working on designing. So that's kind of his part, his baby, and he's been working on it for a couple years now. They've got it validated, and they're putting it actually in the field to test right now. But the engineers that I work with, they often, get very caught up in what their design is and how it's going to work, and sometimes they kind of lose sight of the practical side on, once I get this in the engine, how's it going to react? And so we do a lot of validation testing, a lot of product testing. We do destruction testing, where we'll actually go and we'll cut this up. We'll look at the molecular structure, do the metallurgy on it. So there's a lot of different things that go into making a part that I think technologists in general really can help with. Oh, real quick, we'll talk about Six Sigma. They did not have this class when I went through the program, so I don't know exactly what the class is, but I've actually taken Six Sigma certification both at TRW and then again at Caterpillar. They're very similar. If you are interested in becoming a black belt, I don't know if does that class offer certification? Okay. If the class doesn't offer certification, the ASQ does. So the American Society of Quality, ASQ, yes, they offer a certification in black belt. So if you have time over a summer, you don't have an internship or some time doing something that will really help on your resume, I would suggest working with the black belt community to do a certification. We had some people do this a couple years ago, and they came in and they did a project with us, because you have to have, I think, a project to launch it. But they did a project for their black belt certification, working with our manufacturing team on crankshafts. So if you have any interest in manufacturing at all, the black belt certification is something that would really, really benefit you. And as I said, I've done it twice. I've also had the opportunity to teach some black belt. So once you become a certified black belt, then you can teach others, and you can also teach what they call a green belt, which is a little bit less involved than black belt training. But in Six Sigma, it is huge. It's a big, big kind of buzzword for a lot of manufacturing plants, and a lot of people put a lot of stock into Six Sigma processes and process improvement that way. So, have you guys heard of Six Sigma before? Sort of, kind of? Yeah. Anyone done the Six Sigma certification? No? It's really interesting. You should really take some time to do it if you have time. Good summer project.
Anybody remember how many defects Six Sigma is?
How many defects?
My class should know that.
It's going to be on the test.
3.4 defects per what? Per million chances of making a defect.
Yeah. So, I mean, Six Sigma is hard to attain. I mean, if you're going to make 1 million parts and you have 3.4 defects in that million parts, that's pretty good. But that's what a lot of these processes work towards, is the prevention of defects. So, and if you think about it, like this casting right here of a piston, I mean, that thing is probably around $500 a piece. You don't want to make a lot of defects of those, because it's going to cost you a lot of money. So when you get into those parts that are very highly specified, they have, a lot of things that could go wrong. They're very expensive. The more defects you make, the less money you're going to make, because it's going to be difficult for the bottom line. You guys may know some of these, but I want to throw a couple industry terms at you. So we've been talking about assembly and manufacturing. So one of the things that every manufacturer has to decide at the very beginning, okay, company XYZ is going to start up and we're going to make widgets. Well, of these widgets, what are we going to make? What are we going to buy? And what are we going to manufacture? So it's often called a make-buy decision. So for Caterpillar, remember I told you a couple slides back that we assemble and we manufacture? So we decided as a company that these are the products we're going to make. So this was our make decision. And when we manufacture these, we decided that the block, the crank, the rod, the head, those components that we thought we could do the best, no one could do them better than us. It was not cost effective to have anyone do them better or have anyone manufacture these. So that was our make-buy decision that says, we're going to do these in-house. This is going to be our process that we're going to develop. So for those 4 components, that's what Lafayette decided we're going to make in-house, is the block, rod, crank, and the head. So that's the first decision. And then you have all these material processes that feed into that. So we decided everything else on this engine, there's, I don't know, probably 3,000 parts that go on an engine. We make 4 of them, okay? So everything else we have to buy. So when you're working with that many suppliers, I think we have, I want to say about 1,600 active suppliers right now just coming into the Lafayette plant. So with 1,600 suppliers, we're buying a lot of different parts from them, and we have to control all of their processes, control all of their quality, because they have 3,000 parts coming to build this engine, and we've only manufactured 4 of them. So that's a big undertaking when you're looking at that many suppliers and that many parts, because you really have to understand what are you putting on your product, what are you assembling, because any one of those that has a defect could cause a defect in our product when we go to assemble. So it's really important that the make-buy decision is there. And you guys will find in companies that you go to work for, some of them are and others are strictly manufacturing. They don't do any type of assembly whatsoever. They only produce a manufactured part, and that's their final product. So it varies all across the scale from how many parts you're going to make to how many parts you're going to assemble. So these processes, castings, forgings, fabrications, I'll stop there for a minute. Those have been around forever. I mean, they were probably in your textbooks, I'm guessing. Maybe. But they've been around just forever. They haven't changed. A casting is a casting, and a forging is a forging. And I'll show you some pictures of these. But when these processes were developed, they were very crude processes to get metal into some state, is basically all they were trying to do. So in many of these processes, the core of them hasn't changed, but what has changed is how to improve those processes to make them better. So as you're working toward 3.4 defects per million, if you're working towards a Six Sigma level, you have to figure out where those defects are coming from and how to prevent them. So the process itself is the same as it's always been. The improvements to those processes is what we focus on in manufacturing to make sure that we're getting a quality product. There's a couple other pictures here. We do some of this when we're manufacturing our blocks and cranks and heads. We have some tapping processes. We have a lathe that works on our crankshaft. And we have some drilling processes. Obviously, we have a ton of other processes. Milling operations, boring operations, grinding operations, cutting operations, all of those types of things. And in the manufacturing side, when you're actually, we call it cutting chips, when you're actually manufacturing a part from metal, all of those things come into play. And quite honestly, Caterpillar is so big, we have experts at the Tech Center who know all of these processes very, very well. Many of them are PhD level people who have studied material and metals and these processes. And when we have problems, we have resources that we can call at the Tech Center to say, hey, we have a problem with a milling operation or a drilling operation or a boring operation, and we need some help. So, if you aspire to be, we call them stewards, but if you aspire to be something like that where it's very technical and very focused, there's lots of opportunity for that if manufacturing seems to be your thing. How am I doing on time? Okay. So as I promised, just a couple pictures. Castings. These are our engine blocks and pistons. We have tons of other castings, but there's just way too many to mention. Our manifolds are castings. Lots of other parts that we have are formed from a casting process. But you can see, and you guys will go over this in other, I think materials class, maybe. Do they still go to the foundry? Do we still pour in the foundry?
Some. Yeah.
Okay. Purdue actually has a foundry that we used to pour parts in, which was really, really cool. So hopefully you guys get to do that. If you don't, visit a foundry sometime. Even if you want, call me. I can get you into probably 15 different foundries that Caterpillar has or that we work with to see this process, and it's a really, really neat process to see. An engine block for us is probably, on average, about the length of this table right here. So watching them pour an engine block is kind of a really cool thing. We watched them do that in Illinois a couple times. But what they do is, the process is that this molten metal that's what's in that bucket right there. It's actually metal in a liquid state. And that's what they're pouring it into to form some rough casting. So it's a pretty interesting process. But like I said, these processes haven't changed. It's just how to improve them to make them better. And different ways of casting, there's sand casting, investment casting, permanent mold, experimental mold. There's different ways that you cast based on what kind of part you want to end up with. But at any rate, after casting or a forging process, you're still going to have to do some type of machining to it. This gets it in like a rough kind of state, so you just have kind of a piece of metal that's got some bends or some, geometry to it, but it's really not formed in a piece that you can use. So it does usually have to go through some type our crankshafts and our camshafts. It's obviously done with heat and force. And a couple of pictures, what it's showing you there is they take the metal in its state and heat it up, and then press and hammer and forge into kind of whatever shape that they want to get it to the part that you're going to be using in assembly. Have you guys heard of these before? Is it brand new to you? Okay, awesome. So you guys had some materials background, maybe? Okay. So one thing that has changed a lot. So those processes, like I said, haven't changed, but they've had a lot of improvements to them. But one thing that has changed dramatically, and if you guys want to get into a field that is changing so rapidly that you have to really struggle to keep up, it's electronics. So what we've done is we found that we can control a lot more with electronics than you can with mechanical means. So all of our, I would say all, 90% of our engines are electronically controlled. They're not mechanically controlled anymore. And so we have very sophisticated engine controls, and what these electronics are doing is they're sensoring and gathering data all the time. And as they're doing this, they're making adjustments to air, to fuel, to load, to speed. They're adding water, they're subtracting water. They're making all these adjustments on their own. And the neat thing about electronics is it also protects our product. So if something is going, if the data is showing that, hey, I'm going high speed, there could be something wrong, the engine will automatically shut down. So all of these, we call it e-stop, and emergency controls, emergency stops. All of those things are coming from the sensors of the electronics that are monitoring throughout the entire engine. I know you've been in the test cell before, but when we test an engine and we have electronics coming out of it, it looks like it's some weird science project, but you have probably 1,000 different leads that are tied to every part of the engine, so we can sense what's going on. We can sense the temperatures of the exhaust, we can sense the temperature, the ambient temperature, we can sense anything that's going on so we can make adjustments to it. So the electronics portion is what is just amazing as far as what's changing on our product all the time. Another thing that electronics does is it allows for some flexibility. You guys probably have heard in the news or what have you that diesel fuel does this or natural gas does that, or maybe the availability of different gases or different fuels. So some of the things that we're doing, we have an engine that's a dynamic gas blend, and what our electronics allow us to do is mix diesel fuel and natural gas, and we can adjust how much of each we need. It also allows us to run on this gas diesel mix depending on what all the other factors are. So it continually adjusts the engine and adjusts the performance of that engine based off of the fuel. So if you think about it, if we're going to set some engines in the middle of Siberia and they don't have access to the type of fuel that we have in the States, well, we better find a way that we can continually run those engines based on whatever fuel they have. So it's a major operating expense to bring in fuel to a different area. And so if you can adjust your engines to run on whatever fuel they have, obviously you're going to have a lot better place in the market. As I mentioned, not all places have the same quality of fuels. So different gases all have different types of blends of natural gas. And so these electronics allow you to adjust from that and be able to run the engine the same way as if it was running on straight pure diesel fuel. The electronics also allow us to regulate. You guys have all heard of the EPA and regulations from the EPA. We follow those. We have to recertify every single year, and we have to make sure that we are compliant with all of the exhaust for our product that is EPA compliant. So we're using electronics to do that, to control those particulates coming out of the engine, to control the exhaust, and to control exactly how much pollution is coming from those. So Anyone interested in electronics at all? Maybe? It's a really, really good field. As I mentioned, this is just a picture of our assembly. And this is, you can kind of see, that's kind of a good picture of how big the engine is. These guys are working on the main line. You can see at the bottom, it's actually a conveyor. So those slats are moving in one direction. So it's on a conveyor belt. The engines sit on the conveyor until the final assembly of them, and then they come off the conveyor and then go into the test cell. Now, in Lafayette, we test every single engine. We bring it up to full load every single time. Some engine manufacturers, they do a cold test or they just test randomly, but we test everything that leaves our plant. Everything has to pull full load, and it has to go through a 20-minute test to make sure that everything's working correctly. In our development cells, we have research and development cells. Some of these tests will run 85 hours, so we'll have an engine that's continuously running for about 85 hours to collect data on it. And some of that's required by the EPA that we test, like ever so many engines has to go through an extensive test. So we do some of that testing as well. That's all done at the Lafayette facility. Does it look kind of big? Does it look bigger than your car engine? Should be a little bit bigger. And everything's painted yellow, of course. One thing I will mention also, since our main focus is assembly, like I said, we only make 4 parts. A lot of these requirements from our suppliers are placed because we want to make our assembly faster. So you see parts that are already yellow, the supplier painted those for us. So when we go to assemble these, they've already got paint on them. So that just helps us in our process. Those are just areas that we don't have to touch up with paint. We use paint as a rust preventative, obviously, but a lot of the things that we require our suppliers to do help us in the assembly operations. So you'll find that in process improvement, we're trying to build our assembly more efficiently. We're trying to be efficient and faster in assembly, and things like that, like a supplier is painting a part for us, that's one less thing that we have to do. So if we find that it's cheaper to pay them to do it than have our guys do it, that's a process improvement idea. So we actually have teams that walk through the shop once a month, and then we turn in process improvement ideas, stuff that we've seen that we can have implemented to make our process more efficient in assembly. Okay, I have some advice for you guys. You may not want to hear it, but I have some advice anyway. Go get an internship. If you have any time, whether it's paid, whether it's not paid, if it's summer co-op, it doesn't matter. I remember sitting in 104 and some of the earliest classes that I took at Purdue, and it was so much easier to relate to what they were talking about because I'd actually seen some of these processes. So the more you can go out in industry and see, even if it's a shop tour, even if, hey, my uncle works at XYZ, go look at the plant, go through it, go understand what they're doing. Because for me, the more you see in operations, the more you understand how to help. So I think an internship is probably the best time you can spend in the summer or co-op, or even if you find yourself where, hey, I gotta take a semester off for whatever reason, go get a factory job. It will help you, I promise. And that's our next line. Spend some time in the not so glamorous jobs. Some of these jobs will help you immensely. A lot of people said, why in the world do you want to go work in the dirty factory? And I'm like, well, I don't know that I do, but I'm going to try it anyway. And I learned so much from the not so glamorous jobs. There's been several jobs I'm thinking, oh my gosh, why in the world did I take this? But you learn from it. You really, really do. So don't be afraid of the non-glamorous positions where you think, this isn't going to help me at all. It really will. It gets you a foot in the door and it learns you're learning more processes. So I just want to give you guys a little bit of flavor companies like Caterpillar, they really allow you to move around. If you get a degree, you get your bachelor's, they're going to allow you to move around into other disciplines. I've been in many of these disciplines. I've never worked in accounting. And I've never worked in marketing. So those are really the two that I haven't hit yet. I don't think I want to go to accounting, so I may skip that one altogether. But I do work with the accountants, so I know what they do. I have an understanding of how they have to cost our product and things like that. So I have an understanding of accounting. It's not something that I probably will pursue. Marketing, I would like to do sometime. Marketing is one of those where it requires a lot of travel, though. So I haven't done it as of yet. But just so you know, the bigger companies, they really allow you to move around, and it's kind of independent of your degree. So it's really whatever you decide to do. There are people, I know many of them, who spent 40 years in the same job. They like it, they don't want to do something different, and that's okay, you can still do that. But in some of the larger companies, you have so much more opportunity to move around and do different things. So think about long-term and flexibility. Like I said, one field versus a ton of fields. If you want to move around and get lots of experience, in fact, our general managers, they have to have, we have a profile at work that has different departments that you've rotated through. And for you to become a higher level manager, you really have to have an understanding of many of those departments. So they really stress that they want you to move around so that you understand what all the other groups are doing so you can manage at a higher level. So one of the things that CAT kind of stresses is overseas. So overseas opportunities, with Caterpillar being in 200 different countries, you have a lot of overseas opportunity. I can sit at my desk tomorrow and bring up every job that's open in the entire world. And I can see Singapore and China and Germany and wherever. Every job that's open in the whole world I can see. And you're encouraged, after talking with your supervisor, to put in for those jobs if that's something that you'd like to do. So moving overseas, a lot of opportunity in other countries if you're working for a big company. So you kind of have to maybe take the good with the bad. And that's why I put a couple other things on here. Networking is really important. As you get to work in different facilities, you get to know more people, so it expands your network. One thing I'll say that I don't like about a big company is there's a lot of bureaucracy. It seems like the larger a company gets, it's kind of like the government, it kind of becomes more and more out of control. I know that Purdue kind of does that. You get things in committee all the time, and we do that sometimes at work where you go to meeting after meeting after meeting and nothing gets resolved because of some of the bureaucracy. So I think in smaller companies that doesn't happen as often. It still happens, but not as often. Smaller companies, usually there's a small group of leaders who make the decision and you can go forward and you don't have kind of the red tape, bureaucracy, corporate rules maybe that we have to go by. So. A couple other things on continuing education, as I mentioned. It's really important if you're looking towards a master's degree, if you're working for a company, I strongly suggest that you look into what they pay to get a master's degree, because it's a huge, huge benefit for you to have someone else pay for that. And with the companies I worked for while I was getting my master's, they allowed time off to go, do research, and I actually used my own supply base, the suppliers who I was working with as part of my thesis. So it worked out well that I could kind of combine the two, and my work got something from it. I was able to graduate. It kind of worked out for both of us. So just keep that in mind. And mentors, I don't know if you've done any mentoring yet, but one thing we've kind of learned is how to mentor, be a mentor. And when I was as an internship and as a fairly young person just starting out at CAP, I would find people who knew the systems well, or who knew a process well, or who were well respected, and I would ask those people questions so they were my mentors. And then a few years ago, people started asking me questions, and I'm like, well, why are you guys asking me? And I'm kind of looking around like, oh, I'm not the youngest one here anymore. So you kind of move into that role of, oh, now I'm the mentor. mentor. I give a lot of talks to specifically women in technology and engineering, talking about how to kind of get into some of the male-dominated roles and how to work with more male-dominated disciplines such as engineering. I think in our business at Lafayette, I can count about 10 women in engineering, maybe 15, and that's not very many, but there's a lot of people, for women at least, that are in other types of roles that are less technical. So I help a lot of people kind of transition into those technical roles. Whether they're young people or whether they're women, it really doesn't matter. They kind of look to me to transition into those roles and get something out of an engineering experience. Huh? Okay. Yeah, that was it. Just a few more comments on continuing education. At CAT, they kind of place a higher emphasis on experience as opposed to education. There's not a whole lot of people who have a PhD at CAT. There are some people, like I said, the technically advanced people at the tech center, those types of guys have those. For the most part, if you have a master's degree, you're going to do just fine. Did you guys have any questions for me?
Anybody have any questions? Yeah, say it real loud.
Who oversees how necessary it is to know the language?
It's not. You know what's crazy is I have several friends who went to China. One of my best friends and his wife moved over there, and he had a language coach. And so you can take the language if you want and learn it. Everyone speaks English there, so he kind of thought it was a waste of time, and he thought, oh, I'll do it anyway. He spent about 2 days with this language coach, and they fired him because the language coach asked him to pick a Chinese name. And he goes, but I already have a name. He goes, yeah, but you need a Chinese name. He's like, well, I don't want a Chinese name. So he fired him. So in our experience, it's been, you do not have to know the language at all because you have people who help you all the time. So, I mean, it may be beneficial. I think you're going to learn some Portuguese or Spanish or something, even at your age. So that's pretty good. But we haven't really had that problem. I mean, so many people in our other plants speak English that every single meeting I have with China is all in English. We have a lot of meetings with China.
One of the things you'll find out as far as the language goes, that technology around the world, the language that people pretty much stick to in the technological world is English.
Yeah.
Okay? So when you're dealing with technology and engineering, you deal a lot in English.
And in some languages, there's not even a word to describe it. Like when I was in Mexico and we have the prints laying out on the table, they would be speaking in Spanish, and then you'd hear the word tolerance because they didn't have a Spanish word directly related to the word tolerance, what we call tolerance on a print, and so they just use the English word. So in most technical conversations, English is the language.
Any other question? Yeah.
Are designs in metric or are they in academia?
They're in both. Most of our designs are in metric. We do have some that were never converted. And Caterpillar obviously started way back in the 1900s, and many of them were not metric. They did a conversion to get everything to metric, and then they did another conversion to get from a 2D print to a 3D model. So one thing I will say about CAD is they're kind of slow in getting to that. They eventually get there, but they pretty much, I'd say 90% of it is in metric. But then sometimes they'll give dual dimensions in metric and, English stuff. Yeah?
What are the benefits or the differences between Masters in Technology and Masters in Engineering?
So here's my only, I was going to put this on a slide and then I decided not to, but I've been in engineering for 6 years now, and I don't have an engineering degree. So what I have been told as far as my role goes is I can only go so far in engineering without without the engineering degree. That's fine for me. I'm where I want to be, so it doesn't really matter. And I can go higher in another discipline. I can go back to supply chain or operations or what have you. But like the girl who sits beside me, she has a master's degree in mechanical engineering. And so she could do some of the things in engineering that I possibly couldn't do. Does she use that? Not really. It's funny because I just asked her just today, I'm like, hey, can you look at this print with me? And she's like, oh gosh, a print. And I'm like, you're an engineer. This should be your thing. But so
More theoretical.
more theoretical, yeah. Definitely more theoretical. And if you want to go that precise, technical route where you want to give advice on mechanical engineering, then that would be the way to go. I haven't found that I needed it, just in my own experience.
Anything else? We're right at 9 o'clock.
How soon is the competition? Okay.
It's pretty stiff actually. We're struggling to get into some of the markets that our product is actually too costly because we're a premium type product, and so some of it they want a lesser cost. So Komatsu is one of our competitors. Cummins is one of our competitors. We compete with some pretty big companies. And you can coordinate this, but if anyone wants to come in for a tour, you can get with him. He's got my contact information. Let me know. We'll give tours to anyone who wants to come in, get a group together, and you come in and view the factory. It's a lot of fun.
All right. Okay, thank you.
Is this on Monday?